All right, so yesterday we started looking at powers of monomials. Okay, so powers being raised to more powers or exponents being raised to more exponents. Okay, so we learned that we need to distribute that outside exponent to everything that's on the inside. So it gets distributed to the 15 and it gets distributed to that 8m, and we distribute it by multiplying. So we get 15 to the third power and then m to the 24th power. This is absolutely correct, but we could simplify that 15 to the third power by multiplying 15 times 15 times 15. So we get 3,375 and then m to the 24th power. Okay, so anytime that you are distributing, you're multiplying. Okay, so different from yesterday's, 2 days ago's activities where we were adding and subtracting exponents. Okay, if you take a look at number 5, this 7, it needs to distribute to the 4, to the D, and to the E. So we get 4 to the 7th power, D to the 3 times 7 power, and E to the 5 times 7. Okay, so 4 to the 7th power, D to the 21st power, E to the 35th power. Okay, so then like I said, that is a perfectly good answer, but you could simplify 4 to the 7th power. And so that actually equals 16,384, D to the 21st, E to the 35th. Okay, so both answers are absolutely correct. Let's look at number 9. Okay, this 2 is going to distribute to the 3/5, to the A, and to the B. So we get 3/5 to the 2nd power, A to the 6 times 2, and B to the 9 times 2. Okay. So now we have 3/5 squared, A to the 12th, B to the 18th. Now, when you deal with fractions that are being raised to an exponent, it has to go to both numbers. So this is actually 3 squared over 5 squared, which is really 9 over 25. And then we can put the rest of the problem. Okay. Here, this 3 has to go to both things on the inside, and this 4 has to go to both things on the inside. So now we have 4 to the 3rd power and x to the 2 times 3. And then here we have 3 to the 4th power and then x to the 6 times 4. Okay, so now we have 4 cubed x to the 6th times 3 to the 4th x to the 24th. Okay, so 4 cubed is 64 x to the 6th power, and 3 to the 4th is 81 x to the 24th power. Now it turns into a normal multiplication problem, which we learned the last couple of days. So we would actually multiply the 64 and the 81, and we would add the exponents because it's a multiplication problem, so we add them. So 64 times 81 is 5,184, and then we get x to the 30th. So those can be tricky because they're doing two things. First, we had to deal with powers, so we were multiplying, but then we were dealing with a multiplication problem, so we were adding. Okay, so just be real careful, take it step by step. Okay. When you're expressing the area, remember that area is base times height. And in the case of a square, all of our sides are the same. So our base is the same as our height. Okay? So we're basically saying that this is 9c to the 6th d, and we're squaring it because there are two of them. Okay? You can also write the formula as side squared, and that's where I got that squared from. Okay? So because it's a product power, we're distributing it to each piece. So 9 squared c to the 6 times 2, and then d, when there's no variable or no exponent, it's 1. So this is 1 times 2. So 9 squared c to the 12th d squared. And so then that's 81 c to the 12th d squared. Okay. Here again, we have another square. So we're going to take 14g to the 5th, h to the 9th, and we're going to square it to find our area. So it's going to get distributed to each piece. So 14 squared, g to the 5 times 2, h to the 9 times 2. So 14 squared, g to the 10th, h to the 18th. And so then 14 squared is 196, g to the 10th, h to the 18th. And there's your final answer. Okay.